All right, you guys, today we are going to continue with section 11.3. So please find your notes packet, open it up to page, what is this, 7? Where it says 11.3 combinations, okay? A combination of items is different from permutations, okay? A combination of items occur when the items are selected from the same group, kind of like before. No item is used more than once. So if you select a book, you can't select it again, kind of like that. The order of the items makes no difference. So here's my favorite example. Let's say you are getting ice cream. And the ice cream, let's just keep it simple. Let's say it's vanilla, chocolate, and strawberry. When you go to the store and you order that in your cup or a waffle cone, and you tell the person, I want these 3 flavors, give me 3 scoops, and they ask, which one do you want first, second, or third? And you're like, I don't care, whatever, put them in. So that is combinations, because the person can decide however you want it. And how many combinations are there for 6 items? For 3 items, my bad, I just gave it away. 6. There's 6 ways that the person can arrange the ice cream in there, okay? But what if you are very particular about your ice cream, and you're like, the first one that I want to eat is the vanilla. Then I want to have strawberry, and then I want to have chocolate. If the order matters to you or to the problem, then it's permutations. It's the NPR that we've been doing. Combinations, when the order doesn't matter and you tell the clerk, like, whatever, I don't care what you put in first, last, or second, then it's combinations. Go to your calculator. Press math probability. So far, we've been using NPR. That's permutations. That's when the order matters. Think of ice cream. If it matters to you to eat strawberry first and chocolate last, that's permutations. But if you don't care, you're just going to eat the ice cream all in whatever order, that's combination. And factorial, so those 3 buttons, NPR and CR and the factorial, are the ones that we're going to be using. Okay? A permutation is an order arrangement of given group of items. Given arrangement, so it has to be arranged in a specific order. A combination is a group of items taken without regard to their order. It doesn't matter who goes first, second, or last. So permutation problems involve situations in which order does matter. Combination problems involve situations when the order of items makes no difference. So you just have to remember, combination, order does not matter. Permutation, it does. Example 1. For each of the following problems, determine whether the problem is one involving permutation, where it matters what the order is, or combination, when the order doesn't matter. You don't have to solve it. Part A. 6 students are running for student government: president, vice president, and treasurer. The student with the greatest number of votes becomes the president. The second highest vote getter becomes the vice president. And the student who received the 3rd largest number of votes will be the treasurer. How many different outcomes are possible for these 3 positions? So this is permutations, and we would do 6P. How many are we choosing? 3. And the reason this is permutations, because it tells you the first person must be the one with the biggest number of votes. The second is the one with the second number of votes, and so on and so forth. So this is permutations because it matters who gets to be president, who gets to be vice president, and treasurer. B, 6 people, that's my total, are on the board of a supervisor for a neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people? It doesn't say that this person has to be this person has to be that. We just want 3 different committees. So this is combinations, and it's 6C3. We don't have to solve these, Kevin. We don't have to plug this in. You don't have to figure out the numbers because in here it says do not solve. We're just choosing whether it's P or C. Ooh, my favorite problem. Baskin-Robbins offers 31 flavors of ice cream. One of their items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? Because it doesn't say that you want this first, this second, this third, or this order for that, this is going to be combinations, and we're going to have 31, choose 3. How many ways can you select 6 free videos from a list of 200? Oh, thank you. So a list of 200, right? So it's 200, choose 6. It doesn't say you want the comedy to be first. You want drama to be third. You want something else to be second. So if they don't say it matters in what order, it's combinations. In a race in which there are 500 runners and no ties, in how many ways can the first 3 finishers come in? So now it does matter who comes in first, because if that person is first, can they be second? Can they be third? Can they be 50th? No. So this is permutations, and you would do 50p3. Because once you select, or once we have a winner, that person cannot be in a spot that's later in the race. So just like the notation NPR means the number of permutations of n things taken r at a time, the notation NCR means the number of combinations of n things taken r at a time. Okay? Let's actually do some problems with this. On page 8, they show you the permutations formula and they kind of work it out, but we're not going to really worry about it. You just need to know NCR, it's n factorial, n minus r factorial, and r factorial. You don't even have to have this memorized because everything that we will do involving combinations will be on the calculator. So NCR on the calculator will be the way to do these. Example 2. A 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from the 8 people on the Board of Supervisors? So we're choosing 3 people out of 8, and it doesn't really say anything specific about who needs to do what. So this is combinations, and we're going to do 8, choose 3. Take your calculator. It's NCR this time around. So if you guys have the other calculator, you have to put in 8 first, then bring this up. I don't know how the yellow calculator works. How do you do that? Put in 8, and then you have to put in that, and we get 56. Make sure you guys know how to do this. These problems should be like super easy for you because everything's done on a calculator. Try example 2b. So you should have 7, choose 3, which is 35. All right, let's go to the next page. Does this make sense? Is this easy? This is actually the easiest out of the different things we did. In poker, a person is dealt 5 cards from a standard 52-card deck. So every card deck has 52 cards. The order in which you are dealt the cards does not matter. When it says that, that's like the easiest thing ever. You just know it's combinations. How many different 5-card poker hands are possible? So it's 52, choose 5. A lot. Yes. 2,598,960. Make sure you guys can type it in and get that number. Next one. How many different 4-card hands can be dealt from a deck that has 16 cards? So now we do 16, choose 4. We're not going to worry about figuring that one out because it's just a calculator. Example 4. The U.S. Senate of the 108th Congress had 100 members, 54 Republicans, 46 Democrats. They want to form a committee of 3 Republicans and 2 Democrats. How many possible ways are there to select this committee? So you actually have to use separate C's or formulas for each. We're going to do a thing with Republicans and Democrats, and then we multiply them. So let's do Republicans first. We have 54 Republicans, and we're choosing how many Republicans for this committee? 3. Then we're going to multiply this number, whatever we get for this, by 46. Choose how many Democrats? 2. So let's figure out what this is. Let's figure out what this is and multiply them. Okay? All right, if you type this into your calculator, you should get 24,804, 1,035, and there's 25,672,140 possibilities for this committee. Last one. The U.S. Senate consists of 50 Democrats, 49 Republicans, and 1 independent. How many committees can be formed if each committee must have 3 Democrats, 2 Republicans? So it's the same thing, except you ignore the 1 independent because that doesn't do anything. So it'd be 50 Democrats. Choose, how many Democrats are we choosing? 3 times 49 Republicans. Choose 2 Republicans. And then you would multiply this to get the answer, which is, we're not even going to multiply this up. I don't have the answer. But that's what you would do. All right, this is it.